Okay, hello everyone. In this video, we are going to understand the characteristics table of the JK flip-flop. Okay, truth table or characteristics table, which will be useful for understanding the counter. Okay, whatever we are going to discuss in our next class. So here the JK flip-flop is constructed with the help of NAND gate latch, and here another two NAND gates are attached with this latch. Okay, this is the NAND gate latch. Okay, so here the output of this one is connected with this NAND gate, output of this one connected with this NAND gate. So here this is your J and K value we are going to be consider. This is your J and K value, or considered as set, J for set, K for reset, and this is the truth table for, and this is your QT value, this is your QT, and this is your QT bar complementary. Okay, so for QT initial value, if QT initial value will be 0, and for different values of J and K, whatever the what will the output and its complementary, that we are going to be check. And then if initial value, that means QT will be 1 1 1 1, means QT will be 1, then for different JK values, what will be the output and its complementary, the complementary value, that we are going to check. Okay, so here first we have to consider this one. QT is your 0, we consider that QT is 0. Okay, QT is 0, then what will the value of QT bar or complementary of QT, that first we are going to check. First we have to consider this case. QT is your 0, I consider the initial value QT is 0 and J value 0 and K value 0. Okay, then what will the value of QT and QT bar, that we are going to check. Firstly we consider QT value is 0, for J0 K0 what will be QT plus 1 QT bar, that we are going to check first. Okay, so here as I told that for NAND gate, if one value will be 0, then it will be 1. So here 0 means it will be 1, and 0 means this NAND gate will be give you the 1 value, right? So here 1 means the second input value we are going to check. The second input value will be 0, because initial value we consider 0. So 0 1, that means it will be 1 as it is NAND gate. Okay, so this one is going to be input for this NAND gate, and here 1 is there, so 1 1 will be 1, but NAND gate means it will be give you the value 0, right? So here we found 0 and 1, 0 and 1. So Q bar we found 1 and Q T plus 1 we found 0. There is no changes of the initial condition, right? Now we are going to consider this one. QT is 0, J 0, K 1. So J0 I considered over here, K1. J0 means this value will be 1. Okay, so here 1, clock pulse always 1 and 1. So here 1 means this input value we are going to consider. This input value is how much? 0. Okay, this input value is always 0. So 0 inserted here means this value will be 1. Okay, so here you can see that this value is your 1 and this value is your 1. So now we are going to check the another input value. The input value for this one will be how much? This one is your 0, right? Because we consider the initial condition is your 0. So 0, this one will be 1, and this one again input, it will be input for this NAND gate, already 1 is there. So answer will be 0. Okay, 0. So here we found 1 0, that means Q bar 1 and this is 0, right? Now we are going to consider this one 1 0. J is your 1, K is your 0. So here 0 means this value will be 1, and here 1 is there means clock pulse 1. Now we are going to consider this input. This input is nothing but 1, because QT bar is 1. So QT bar 1, this one, that means this value will be 0, and if this value will be 0, the output will be 1. Okay, output will be 1, and this output 1, and this one is going to be feed to this one. So this 1 1 1, but NAND gate will be there means it will be 0. right? Now we are going to consider 1 1 situation. If j is 1, see here we found 0 value. Here I am going to write 0 value, right? So 1 0 we found. So qt plus 1 is your 1 and qt is your 0. Okay, now we are going to consider, here you can see whenever we consider the set state, then the output is your 1 and this is 0. Now we are going to consider this condition, that means qt is your 0 and j is 1, k is 1, then what will the value of qt plus 1 and qt bar? Okay, so first we have to input j equal 1, k is 1. Okay, as this is 1 1, then clock pulse is always 1 1, so we have to consider this input and this input. Here you can see this input is connected with qt equal to 0. Okay, so when qt is 0 is going to be fed with this NAND gate. Any 1 0, we know that for the NAND gate any one of the data will be 0, the output will be 1. So this is 0 and 1 1, so this value will be 1. Okay, any one of the input will be 0, so value will be 1. Okay, now here you can see that for this one we have to consider this input. So this input is your 1, so 1 1 1 1 1, so that means we are going to get output is 0. So if this is 0, then as this is NAND gate, one of the input will be fed to this NAND gate, the output will be 1. So this output 1 again we are going to feed with this one, as this is NAND gate, so this output will be 0. Here I am going to write 0. So we found 1 0 1 0. Okay, now we are going to consider if qt is 1 and corresponding jk values, what will be the qt plus 1 and qt bar? Okay, here I consider that qt, this one was our first case, so qt I consider 1. First we are going to consider if qt is 1, then what will the qt plus 1 and corresponding qt bar? Okay, so here we consider j value 0 and k value 0. J value 0, k value 0, as these two values are 0, so then this value will be 1, this value will be 1. I am going to write over here 1 and this value will be 1, because input, any one of the input will be 0, then means this will be 1, this will be 1, right? So now here if this is 1, this is 1, then we are going to consider another input values. So here you can see this input value is 1, so whenever it will be fed with this NAND gate, already 1 is there, 1 1 will be 0 for the NAND gate, so it will be 0. And if 0 is going to be fed with 1, then the output will be 1. Okay, so here we found initially 1, if it is there, then the output will be 1 and 0, that we are going to write 1 0. Okay, now we are going to consider this one 0 1 condition. 0 1 condition means 0 for 0 it will be 1. If it is 1, then we are going to consider another input. So another input is nothing but is your 1. So here 1 and this is your 1, so output will be 0. If it is 0, then output by this NAND gate will be 1, right? And here this one is going to be fed with this one, it will be give you the value is 0. Okay, so we found just altered that this value we found 0 and this value we found 1. Okay, now we are going to consider this one 1 0, as this is 0, the output of this NAND gate will be 1, right? And we are going to consider this is 1, means we are going to consider this input. This input is always what? If it is 0 1, so it is 0. Okay, it is 0 always, so this will be 0. So this 0 is going to be fed with this one, then output will be 1, right? Output will be 1. So here this is 1 and this is 1. So for this one, if we are going to consider this one is going to be input for this one, another input we are going to consider, another input is always what? 1 we consider, because qt is 1, so 1 1 1 and this is your 1, the answer will be 0, right? The answer will be 0. Q bar, see, any here 1, here 1, 1, already 1 is there, initial condition is 1, 1 and this 1, 1 1 will be 0, and this 0 if will be inserted or feed with this one, then the output will be 1. So here we found for this case this is your 1 and 0, right? 1 0. Now we are going to consider 1 1 case. 1 1 case, 1 1 case means we have to consider the third input. Here third input means this one is your qt, we considered that 1, right? So 1, here 1, 1 1 means this will be 0, and here qt is 0 and 1. So this if this 0 is going to be fed with this one, this answer will be 1, right? And as it is 0, the output will be 1. Okay, so this one is going to be fed with this NAND gate, already 1 is there, so it will be 0. So qt we found 0 and qt bar we found 1. Okay, so here this is the truth table of characteristic table or truth table of JK flip-flop, which will be useful for understanding the counter. How? Here you can see, you just mark that this value when j value k 1, k value 1, if qt is 0, then qt plus 1 will be 1. For this case here, if j value 1, k value 1 and initial value is 1, then it will be output will be 0. These two output you just remember. Okay, here you can see j value 1, k value 1, initial state is 0, then output will be 1. If j value we are going to consider 1 1 and initial state is 1, then it will be converted to 0. That means 1 it's complementary, converted to its complementary. If 1 initial state is there, then it is converted to its complementary 0. Okay, so thank you so much for watching this video. You just remember these two. Okay, so these two are also called as the toggling case. Okay, so you just remember that qt 0, it will be 1, 1 it will be 0, output will be 0. Okay, so thank you so much for watching this video. Thank you.